Introducing the roots of a quadratic equation as a topic. This is Kisembo Academy. The roots of a quadratic equation, we may call them the solution to a quadratic equation. But first of all, a quadratic equation is always in the form ax squared plus bx plus c, where the value of a, b, and c are constants. Now, if we are to find the solution to that quadratic equation, we shall use that formula. X is equal to negative b plus or minus under the square root b squared minus 4ac over 2a. Now, in that bulldozer method, the method that we use to solve a quadratic equation, the term b squared minus 4ac is referred to as the discriminant. And the discriminant is what determines the nature of the roots of the quadratic equation. So now let's explore the possibilities here. So now if b squared minus 4ac, this part of the formula, if it is equal to 0, it means that the roots of that quadratic equation are real and are repeated. If b squared minus 4ac is equal to 0, it means that the roots are real and repeated and therefore are equal to negative b over 2a. Now, if b squared minus 4ac is greater than 0, then the roots are different. It means that either x is negative b plus or minus b squared minus 4ac over 2a, or x is negative b minus. The difference lies here. One is a positive, one is a negative right there. Now, if b squared minus 4ac is less than 0, then the roots are imaginary. Why are they imaginary? Because now if this part of the formula is less than 0, it means we are going to find the square root of a negative number. And since the square root of a negative number does not exist, it only means that the answer we shall get there, the root of that equation, will just be imaginary. In essence, if b squared minus 4ac is less than 0, then the roots are imaginary since there is no quantity whose square root is negative. So let's explore some examples here, some illustrations here. State whether the following equations have two real and distinct roots, real roots or repeated roots. Let's look at Roman 1 here. Roman 1 is 4x squared plus 3x minus 12 is equal to 0. We know that 4b squared minus 4ac, which is the discriminant, should be equal to, we now find out, this is a, according to the general formula, this is a, this is b, this is c. So we substitute in here. What is b squared? B squared is 3 squared minus 4 times a, which is 4, times c, which is negative 12. So we shall end up with, now of course here we are going to get a negative answer, and 9 minus that negative answer, we are going to end up with a positive answer, and the positive answer we are going to get here is 201. So since b squared minus 4ac is 201, it means that b squared minus 4ac is greater than 0. And according to our previous assertions here, we say that if b squared minus 4ac is greater than 0, then the roots are different. It means that the roots are, they are 2 and they are different. It means that in this case, for this particular number, we shall conclude by saying that b squared minus 4ac is greater than 0. Therefore, the roots or you can say that there are two real roots that are distinct. Let's go on to Roman 2. Roman 2 is 4x squared plus 8x plus 4 is equal to 0. We want to find the nature of those. Like before, we say this is our value of a, that's our value of b, that's our value of c. And now with us we seek to find with the nature of the roots. So it's still going to be b squared minus 4ac. It's going to be b squared, that is 8 squared minus 4 times a, which is 4, times c, which is 4. So that's going to be 64 That is what it means. It means that the equation has repeated roots. As simple as that. If 8x squared minus 8x plus p is equal to 0 has a repeated root, find the values of p. So if you are to find the values of p, we know that for repeated roots, just like we saw before, the discriminant, which is b squared minus 4ac, is going to be equal to 0 for repeated roots. So for a number like this, for us to find the value of p, if that equation has repeated roots, it means you're supposed to simply substitute in that expression using that equation so that we're able to get the value of p, since that we have been told that that equation has repeated roots. So we know that 8 is the value of a, that is negative 8 is the value of b, and positive p is the value of c. So b squared is negative 8 squared minus 4 times a, which is 8, times c, which is p. That should give us 0. So now let's go to a different kind of numbers. We are going to look at numbers that are going to require us to find the range of values of certain variables within quadratic equations. This example is asking us to find the values of lambda, for which the equation x squared minus 6x minus 1 plus lambda into 2x plus 1 is equal to 0 may have real roots. Let's rewrite that equation first. X squared, we want to find the range of lambda. Now if you are to find the range of lambda, which will be such that this equation has real roots. If it has real roots, it means that the discriminant, which is b squared minus 4ac, is greater than or equal to 0. So it means you're supposed to rearrange this equation. After rearranging that equation, we substitute the terms a, b, and c in the expression b squared minus 4ac is greater than or equal to 0. We say greater than or equal to 0 because that is the condition for this equation to have real root. After substituting that, then lambda 2x plus lambda is going to be equal to 0. X squared, we collect like terms. We put the expressions with x alone, that is minus 6x plus lambda 2x, then we have plus lambda minus 1 is going to give us 0. So if that is giving us 0, so we'll end up with the quadratic expression in x is going to be x squared minus, put this minus x into 6 plus lambda minus 1 is equal to 0. So we formed the quadratic equation in x. By quadratic equation in x, I mean this is our value of a, this is our value of b, this is our value of c. We are looking at a quadratic equation in this form that, since this quadratic equation has got real roots, it means that the b squared minus 4ac is greater than or equal to 0. So what is b squared? In this case, b squared is 6 minus 2 lambda. So we shall go ahead and say in bracket 6 minus 2 lambda close bracket squared, subtract that from 4 times the value of a. The value of a in this case is 1. Actually it's the coefficient of x squared, which is 1, times c. The value of c is lambda minus 1 times lambda minus 1 is greater than or equal to 0. So we proceed with our calculation. We shall end up with 6 minus 2 lambda into 6 minus 2 lambda minus, this is going to be 4 into lambda minus 1 is greater than or equal to 0, minus 28 lambda plus 4 lambda squared is going to be greater than or equal to 0. If we divide through by 4, we shall end up with 10. So we are going to end up with a quadratic equation here in lambda is either lambda is equal to 2 or lambda is equal to 5. As far as our question is concerned, we find the values of lambda for which this equation may have real roots. So we are supposed to test for which range will satisfy that equation to have real roots. So we have here that the value of lambda is 2 less than lambda less than 5. Here we have here that the value of lambda here is greater than 5. Then the value of lambda here is less than 2. So let's pick a number below 2. Let's pick 0. And if we pick 0 and we substitute it into that expression that supports this expression, of course this expression has been simplified to this. This is the expression, the discriminant that says that b squared minus 4ac is greater than 0. It has been simplified to this. So if we just substitute in there and we see if this range or that range or that range will support this assertion. So if we pick a figure below 2, let's say we pick 0. 0 minus 2 here will be negative 2. Negative 2 times negative 5, if this is 0 of course. Negative 2 times negative 5 will give us a positive 10. So we ask ourselves, is positive 10 greater than or equal to 0? Yes. So what does that mean? It means that x less than 2, it satisfies that range. We come and test here. 2, 3, 4, 5. Let's just pick 3 here. If we come and substitute 3 in this expression, 3 minus 2 is 1. So, and here 3 minus 5. 3 minus 5 is giving us negative 2. So, this is 1 times a negative 2. It's going to give us a negative answer here. A negative answer is definitely less than 0. It's not greater than 0. So it means this range from 2 to 5 does not qualify. So we proceed to lambda is greater than 5. Let's pick 6. If we come and put 6 is 6 minus 2, we have 4. So, and here 6 minus 5 is 1. So 4 times 1 is 4. Is 4 greater than or equal to 0? Yes. So it means this region satisfies that inequality. So what does that mean? It means that now we conclude by saying that the range of values here are simply lambda is less than 2 comma, and also lambda is greater than or equal to 5. Find the range of values for m for which that has real roots. So we have our equation there. It is x squared plus mx plus m is equal to 0. But we know that for real roots, that applies for real root. So in this case, our value of b is going to be m squared minus 4 times a, which is 1, times c, which is m, is greater than or equal to 0. So we continue with the arithmetic. M squared minus 4m is going to be greater than or equal to 0. So now, for that matter, therefore, we start looking for the range of values that will satisfy the real roots. So we draw a simple small line. We have 0 and we have 4. So this is the region where m is greater than or equal to 4. This is the region where m is less than 0, and this is the region where we have 0 being less than or equal to m less than or equal to 4. So now which region is going to satisfy this inequality? So the range of values of m, let's pick negative 1 here. If we put negative 1 here, negative 1 times negative 4 is negative 5. Negative 5 times negative 1 is positive 5. Positive 5, is it greater than or equal to 0? Yes. So it means that this range of values is going to be supported. This supports the inequality. So we proceed to this range. Between 0 to 4. Between 0 to 4 there is 1 here. Let's choose 1. 1 minus 4 is negative 3. Negative 3 times 1 is going to give us negative 3 still. Is negative 3 greater than or equal to 0? No, it's not. So since it is less than, it means it's not going to support. So that range does not support. We go to this. M is greater than or equal to 4. Let's choose 5. 5 minus 4 is 1. 1 times 5 is 5. Is 5 greater than or equal to 0? Yes. So it means that this range is also going to support that inequality. So after finding the range of values that satisfy that inequality, we shall conclude by saying that values of m where that equation has real roots are m is less than or equal to 0 and m is greater than or equal to 4. Those are the range of values. Quadratic expression or quadratic equation is always in the form of ax squared plus bx plus c. So for us to know whether a quadratic expression has got a minimum point or a maximum point, we'll simply look at the coefficient of x squared. For a coefficient of x squared that is a positive, we know that that quadratic equation has a minimum point. For a curve with a minimum value, the coefficient of x squared is a positive. And for a curve with a maximum value, the coefficient of x squared is always a negative, like we shall always see. Find the minimum value of 2x squared minus 6x plus 3. Hence, determine the value of x at which it occurs. First of all, it is a minimum value because the coefficient of x squared is a positive, so it's a minimum value. It has a minimum point. So to determine that minimum point, we are supposed to complete squares and formulate that equation so that it is in this form. Completing squares and formulating this equation in form of a into x plus p in bracket squared, it is from then that we shall be able to find the minimum value. The minimum value, which will be the q, will be so only when the terms in the brackets, that is x plus p, are equal to 0, like we shall see in our subsequent example. For example, here 2x squared minus 6x plus 3 is equal to 0. So we pull the 2 out the brackets. When we pull the 2 out of the brackets, it's going to become 2 into x squared minus 3x plus 3 over 2 is equal to 0. So when we complete squares of this, it means that we are going to get the coefficient of x. Get the coefficient of x, divide it by 2. After dividing it by 2, square the answer you get. When you square the answer you get, you're going to add it first to this term, add the answer you get to that term, and then subtract it from that value, c. As simple as that. So in this case, the coefficient of x is going to be 3. So we divide 3 by 2. When we divide 3 by 2, we get 3 divided by 2. 3 divided by 2, square the answer, it's going to become 9 over 4. So we go and add 9 over 4 to that term. So it becomes 9 over 4 plus that, the rest of that term. Plus, then we subtract that 9 over 4 from the value of c, which is 3 over 2. So it's going to become 3 over 2 minus 9 over 4. That's how we complete the square. So if we solve this quadratic equation, we find that this is a perfect square. So it's going to become x minus 3 over 2 in bracket squared plus 6 minus 9 over 4. So our answer here, we shall end up with the expression 2 into x minus 3 over 2 all in bracket squared minus 3 over 2. This is equal to 0, or we call it the function of x. So now the minimum possible value of the expression is going to become, it shall be negative 3 over 2. And it will occur when x minus 3 over 2 is equal to 0. Therefore, the value of x for which that expression is minimum is going to be equal to 3 over 2. So we've gotten our answer. The minimum value of that quadratic equation is negative 3 over 2, and it happens when the value of x is 3 over 2, because this whole thing is supposed to be 0. The next example says that find the minimum value of the function 2x squared minus 4x plus 5 and state the values of x for which it occurs. We are going to use a similar approach to what we've been doing before. We are going to complete squares and make that equation. So the equation is 2x squared minus 4x plus 5. Pull the 2 out of the brackets, it's going to become 2 into x squared minus 2x plus 5 over 2. Just like we did before, we are going to get the coefficient of x. In this case, the coefficient of x is 2. Divide it by 2. After dividing the coefficient of x by 2, we square the answer. When we square the answer, we are going to add it to that term. After adding it to that term, then we get that term 5 over 2 and subtract the answer we got. In this case, it's going to become 2 into, it's going to become x squared minus 2x. So we get negative 2 divided by 2. What do we get? We get negative 1. Negative 1 squared, what do we get? Negative 1 times negative 1 is positive 1. So we add positive 1 here, like that. Then we say plus this 5 over 2. And from that 5 over 2, that positive 1 we got, we subtract it. That is, this is giving us the function of x, which is equal to 0. So this is going to become 2 into, now when you simplify that quadratic expression, it is a perfect square. It's going to give us x minus 1 squared. That's going to be plus, this is over 1. After getting that, we say that the function x is minimum when x minus 1 is equal to 0. Therefore, the minimum value is the minimum value of f of x is going to be positive 3, and it occurs when x is 1, because it occurs when x minus 1 is equal to 0. Therefore, it occurs when x is equal to positive 1. So that is how we solve that question, and that is our answer. Let us do one more number. By expressing 2 minus 5x minus 3x squared in the form of a into that, determine the maximum value of f of x and state the value of x at which it occurs. We are going to use the same approach, but here this quadratic expression has got a maximum value. Why? Because the coefficient of x squared is a negative 3. It's a negative. So because the coefficient of x squared is a negative, it means that this quadratic expression is a maximum. So we are going to calculate for that maximum, but the rest in the same procedure as before. So this is the quadratic equation. It is 3 So now we complete squares here. Still like before, we are going to get the coefficient of x squared is 5 over 3. So we shall get 5 over 3, and what shall we do to 5 over 3? We shall divide it by 2, and then the answer we get is squared. So it's going to become negative 3 into x squared plus 5 over 3x. So we get the coefficient of x, 5 over 3, divide that by 2, it's going to become 5 over 6. 5 over 6, square it, it's going to become plus 25 over 36. So after adding this to that, then we get this, and we say 2 over 3 minus that. Answer we got. So it's going to become minus 2 over 3 minus 25 over 36 is giving us the function of x, like that. x plus 5/6 squared. That will give us plus 49 over, now of course the 36 and the 3 this will give us 12 when we divide them. It will give us the function of x. So we conclude that we say that the maximum value we want to investigate the relationship that exists between roots and the coefficients of a quadratic equation. When I talk about roots of a quadratic equation, in essence, I'm talking about the solution to a quadratic equation. If alpha and beta are roots of a quadratic equation, ax squared plus bx plus c, it means that x minus alpha into x minus beta is equal to 0, and also ax squared plus bx plus c is equal to 0 have the same root. X minus alpha into x minus beta is going to be equal to 0. When we open brackets here, it's going to become x squared minus x beta minus x alpha plus alpha beta is giving us 0. So we shall end up with x squared minus x outside the brackets into beta plus alpha, then plus alpha beta is equal to 0. That's now a quadratic expression in x. Good from expanding that. This, we relate that to this other equation since they are having the same roots. Relating that to ax squared plus bx plus c is equal to 0. When we divide through here by a, so that this goes with that, so that the coefficient of x squared is 1, we have that x squared plus b over ax plus c over a is equal to 0. So what do we see from there? We see that the coefficient of x here and the coefficient of x here, we find that this b over a is equivalent to that. And we also find that this positive c over a is equal to that. From here you see that b plus a, these are roots. The sum of the roots is equivalent to b over a, and the product of the roots, alpha times beta, is equivalent to c over a. So it is against that background that we shall come up with this conclusion for all quadratic equations, that generally all quadratic equations of the form ax squared plus bx plus c is equal to 0 with roots alpha and beta have the sum of the roots alpha plus beta being equal to negative b over a, alpha plus beta being negative b over a, and the products alpha beta being c over a. As simple as that. So now let's try some examples to that effect. Write down the sum and product of the following equations. Roman 1, part A, we have x squared minus 3x plus 2. Now, of course, the sum is going to be equal to negative b over a. In this case, we have negative 3. The sum of it's going to be negative actually positive 3 over a, which is 1. So the sum here is, the sum of the roots is 3, and then the product is simply c over a, which is going to be 2 over 1, which is 2. As simple as that. Let's look at part B. Part B is 4x squared plus 7x minus 3 is equal to 0. We want to find the sum and product of that equation. The sum is going to be equal to negative b over a, which is going to be negative b. B is 7 over a, which is 4. So this is the sum. And then the product is going to be C over A. What is C? C is negative 3 over A, which is 4. So the sum is negative 7 over 4, the product is negative 3 over 4. As simple as that. So from these equations, you will see that this, as long as the coefficient of x squared is 1, it is going to be x squared minus the sum of the roots plus the product of the roots. Because the sum here is 3, the product is 2. It is the same here. If we make x, the coefficient of x squared 1 in that form, for example, in that equation, it will be x squared is equal to 7, x squared plus, if we divide through by 4, 7 over 4, x minus 3 over 4 is equal to 0. If the coefficient of x squared is 1, you will see that the general form of the equation is x squared minus the sum of the products plus the sum of the roots plus the product of the roots. So from that we come up with this general equation of a quadratic equation that should be at your fingertips. The general equation of a quadratic is x squared minus sum of roots times x. Sum of roots is actually the coefficient of x plus the product of the roots. Now remember that we are going to use that x squared minus sum, this is for Roman 1, sum of roots x plus product of roots. So in this case it's going to be x squared minus what's the sum of the roots? Here the sum is 3 plus what's the product? The product is 4. So that's the quadratic equation, as simple as that. Roman 2 is sum is a third, product is negative 2 over 5. So it's going to be x squared minus the sum of the roots is a third x plus the product of the roots, which is negative 2 over 5. So you'll end up with x squared minus a third x minus 2 over 5 as the quadratic equation. Let's do the last one. The last one is saying the sum is negative 2.5 and the product is negative 1.6. So it's still going to be x squared minus the sum, which is negative 2.5 x plus the product, which is negative 1.6. So it's simply going to become x squared plus 2.5x minus 1.6. And what's our answer there? Of course, that's the quadratic equation, but just remove that decimal point. We'll multiply through by 10. The equation becomes x squared, 10x squared plus 25x minus 16. That's the quadratic equation. Express the following in terms of alpha plus beta and alpha beta. Roman 1 is alpha squared plus beta squared. So we shall start straight away with solving Roman 1. Forming alpha squared plus beta squared in terms of this and that, we shall get this from here. Alpha plus beta squared is going to be equal to alpha squared plus 2 alpha beta plus beta squared. If we make alpha and plus beta the subject so that we come up with this expression which is in our question, we shall end up with alpha squared plus beta squared is going to be equal to alpha plus beta squared minus 2 alpha beta. And that's the answer. We have expressed this in terms of alpha plus beta, which is required in the question, and alpha beta, which is that. So that's our answer. Let's move on to Roman 2. Roman 2 is alpha minus beta squared. So alpha minus beta squared, that is going to be alpha squared minus 2 alpha beta plus beta squared. This is going to become alpha squared plus beta squared minus 2 alpha beta. But we already found what alpha and beta is. We already know that alpha squared plus beta squared is this, and it's equal to that. So we shall substitute for this and just bring that expression there. So in essence here, that's going to be equal to, in brackets, alpha plus beta squared minus 2 alpha beta, then minus 2 alpha beta. So our answer will be alpha plus beta in brackets squared minus 4 alpha beta. That's the answer. Let's do Roman 3. Roman 3 is alpha cubed plus beta cubed. Now for alpha cubed plus beta cubed, we are going to use the same technique we used before. We shall get this expression from alpha plus beta all in brackets to the power 3. That is the same as saying alpha plus beta squared times alpha plus beta, like that, plus 2 alpha beta, or plus beta squared. All this is multiply that by alpha plus beta, like that. So we open these brackets. This times that is going to be alpha cubed plus beta. Let's rewrite this down. It's going to be equal to alpha cubed plus beta alpha squared plus 2 alpha squared beta plus 2 alpha beta squared plus alpha beta squared plus beta cubed. So from that expression we make alpha cubed and beta cubed the subject of the formula. So the rest of all this we shall shift it to the other side. But before we do that, I think we can simplify this a bit further to make it a bit shorter. So alpha plus beta cubed is going to give us, let's call this alpha cubed. So that will mean it's alpha cubed plus, let's pull out the common terms here, it's going to be 3 alpha beta into, that's going to be alpha plus beta plus beta cubed is going to give us alpha plus beta cubed. So from there we make alpha cubed and beta cubed the subject of the formula, and the rest goes this side. So we are going to remain with alpha plus beta cubed. This one, this expression crosses the equal signs, it comes this way, it becomes minus 3 alpha beta into alpha plus beta is giving us alpha cubed plus beta cubed. So to just rearranging that will mean that alpha cubed plus beta cubed is giving us alpha plus beta, oh, this is, the cubed is outside here, alpha plus beta in brackets cubed minus 3 alpha beta into alpha plus beta, and that is our answer. In essence, we have expressed alpha cubed plus beta cubed in terms of alpha plus beta and alpha beta. That the roots of the equation 2x squared minus 4x plus 5 is equal to 0 are alpha and beta. Find the values of 1 over alpha plus 1 over beta, plus there is part B and there is part C, and so on and so on. So how do we go about this kind of question? They are telling us, they've given us an equation. The equation is 2x squared minus 4x plus 5 is equal to 0. And they're telling us the roots of this equation are alpha and beta. So it means in these roots, the sum of these roots is supposed to give us a certain number. The product of these roots is supposed to give us a certain number. But from our earlier videos, we explored that the general equation of all quadratic equations is going to always be x squared So we see that this quadratic equation is in this expression. So it means that this sum of roots should be alpha plus beta here, whatever figure is there, and the product of the thing, the roots is alpha beta. From our previous videos, we came up with a conclusion that asserted that generally all quadratic equations in that form, x squared plus bx plus c is equal to 0 with roots alpha plus beta, have their sum of the roots being equal to negative b over a, and the product of their roots, which is alpha beta, being equal to c over a. So in this case, with this equation here, 2x squared minus 4x plus 5 being equal to 0, we know here that the sum, if we made x, the coefficient of x squared to be 1, we'll end up with x squared minus 4 over 2 x plus 5 over 2 is going to give us 0. From the general expression, we know that the coefficient of a here is 1. Our value of b is that. Our value of c is 5 over 2, positive 5 over 2. And when we compare that with the general equation of the quadratic equation, the general expression, which is ax squared plus bx plus c, you will find that the sum of the roots is going to be equal to negative b over a. That's the sum of roots, negative b over a. So if the sum of the roots is negative b over a, it means that it's going to be, what is our negative b? Our negative b is negative, our value of b is negative 4 over 2, which is going to give us positive 4 over 2, which is 2. And what about the product of the roots? The product of our roots is going to be c over a. And in this case, it's going to be 5 over 2. That's the product of the roots. But then we have been told that the roots are alpha and beta. So it means that the sum of the roots, which is alpha plus beta, is going to be equal to 2. And the product of the roots, which is alpha times beta, is going to be equal to 5 over 2. This is the sum of the roots, this is the product of the roots. So that being extrapolated from the question, we can go ahead and start answering the questions. They are telling us to find the values of part A. They are telling us 1 over alpha plus 1 over beta. Now for us to find the value of 1 over alpha plus 1 over beta, we are simply supposed to calculate this expression arithmetic in such a way that we convert it into this form, into forms of alpha plus beta and then alpha beta. At the end of the day, we shall simply just substitute in the values of alpha plus beta and alpha beta, and then we shall get our expression. So here we shall go ahead and find the LCM, which is alpha beta. Alpha beta divided by that is beta up plus alpha. So our answer here is beta plus alpha is 2. Divide that by alpha beta, which is 5 over 2. So it's going to be 4 over 5. Part B is they're asking us to find alpha minus beta squared. Now the expression for alpha minus beta squared, we already got it. They are in our earlier calculations. The expression for alpha minus beta squared, we ended up with alpha plus beta squared minus 4 alpha beta. We got this expression in our first example. We shall not recalculate it. We shall not calculate it again or derive it again. So this is going to be 2 squared minus 4 times 5 over 2. It will be 4 minus by 2 once, by 2 twice. 2 times 5 is 10. That is 4 minus 10. And we shall end up with negative 6. And that's our answer. That is our part B. So we go on to part C. Our part C is asking us to find the value of 1 over alpha plus 1 plus 1 over beta plus 1. Now 1 over alpha plus 1 plus 1 over beta plus 1 is going to be equal to we find the LCM of this. It's going to be alpha plus 1 into beta plus 1. Here we are trying to make sure that we convert this expression in terms of alpha plus beta and alpha beta, so that we end up substituting. So this divided by that is going to give us beta plus 1. So we have beta plus 1 up there, plus this divided by that will give us alpha plus 1. Alpha plus 1 times 1 is going to give us alpha plus 1. So we shall end up instead with this plus that, we end up with beta plus alpha plus 1 plus 1 is 2. Divide all that by this times that is alpha beta plus this times that is alpha plus 1 times beta is beta, then 1 times 1 is 1 plus 1. So the answer we shall get here will be beta plus alpha is 2. Remember, alpha plus beta is 2, the sum of the roots is 2, so it's going to be 2 plus 2, divide that by alpha beta, that's the product of the roots, and according to we find that the product of the roots is 5 over 2 plus alpha plus beta in this case is 2, then plus 1. We find that we are able to manipulate the expressions for alpha and beta. We make sure that we convert them to make sure that alpha, the expressions we see here or any other expression that you're given, you first convert them in the form of alpha plus beta, because you know that the value of alpha plus beta is 2. And you also express them in form of alpha beta, because you know that the value of alpha times beta is the product of the roots which you have been given. And that's how we find our expressions, our answers as 8 over 11, the values of the expressions. The roots of the equation x squared minus 2x plus 3 is equal to 0 are alpha and beta. Find the equations whose roots are alpha over beta, comma beta over alpha. So now from the equation x squared minus 2x plus 3 is equal to 0, we shall find that we've been told that the roots are alpha and beta. So the sum of the root is alpha plus beta, the product is alpha beta. So the sum of the roots alpha plus beta are still going to be equal to negative b over a. These are terms that are within this quadratic equation that has been given to us within the question. So in this case, our value of b is negative 2, which is that. Our value of a is positive 1, the coefficient of x squared. So the sum of the roots is going to be equal to 2. Then the product of the roots is alpha beta, which is still going to be equal to c over a. Our value of c from our equation is 3. And our value of a is still 1. So the product of the roots alpha beta is going to be 3 over 1. And our 3 over 1 is still giving us 3. So in conclusion, from our equation that has been given to us in the question, we find that the sum of the roots, which is alpha plus beta, is going to be equal to 2. And alpha beta, which is the product, is going to be equal to 3. So from this knowledge, we are going to now start answering our question. Our part A is telling us to find the equation, the quadratic equation, whose roots are alpha over beta, comma, beta over alpha. Now, we are going to find the sum of these roots first, but we are supposed to manipulate these two roots in such a way that the expressions we get are in the form of alpha plus beta and then alpha beta. So that in the end we are able to substitute for alpha plus beta as 2, we substitute for alpha beta as 3, so that we are able to get the sum and product of the respective roots, like we shall see in our calculations. So our part A is going to be alpha over beta, comma, beta over alpha. So the sum of the roots is going to be that plus that. LCM of beta and alpha is alpha beta. Alpha beta, divide that by beta, you're going to get alpha. Alpha times alpha is going to give you alpha squared. Then again, alpha beta divided by alpha is going to give you beta. Beta times beta is going to give us beta squared. So we come here from our previous videos, we already derived we already know how this comes about. Maybe just to repeat it afresh, we did the side work here is alpha plus beta. We get it from alpha plus beta in brackets squared is going to be equal to alpha squared plus 2 alpha beta plus beta squared. When we make alpha and beta squared, alpha squared and beta squared the subject of the formula, so that we obtain this expression, we end up with alpha plus beta in bracket squared minus 2 alpha beta. So this expression, we substitute for this here. So we end up with alpha plus beta is 2, so it is 2 squared minus 2 times alpha beta. We have beta there. So it's 2 minus 2 alpha beta, so it's going to be 2 times alpha beta, which is 3. So 2 squared is going to be 4, and 2 times 3 is 6. So 4 minus 6 is negative 2 divided by 2, we will end up with negative 1. So the sum of the roots here is negative 1. After finding the sum of the roots as negative 1, we go ahead and find the product of the roots. The product of the roots, it means we are going to multiply the roots together. So here, the product of the roots give us this times that. We have alpha beta divided by alpha beta, which is going to be 3 over 3. 3 divided by 3 will give us 1. So after finding the sum of the roots as negative 1, the product of the roots as 1, we go ahead and substitute it in that expression. X squared minus sum of roots plus product of roots. In this case, it's going to become x squared minus the sum of the roots is negative 1, x plus the product of the roots, which is 1. So our quadratic equation here is going to become x squared, this times that is, plus x plus 1. That is the quadratic equation we get in that case. So we shall go ahead and do our part B. Part B of this question is find the equation, find the quadratic equation when you've been given these roots. The roots here, the first one is alpha minus beta, comma, and the second is beta minus alpha. We are going to do this number like the way we did in the previous one. So we shall go straight ahead and find the sum of the roots. Of these roots will be alpha minus beta plus beta minus alpha. That's going to be equal to, now you find that alpha minus alpha will be 0. Negative beta plus beta will be 0. So it means here the sum is 0. So let's find now the product. The product of the roots, we are going to multiply those two terms together. So it's going to become alpha minus beta times beta minus alpha. That's going to be this times that is alpha beta. This times that is minus alpha squared. This times that is minus beta squared. Then this times that is positive alpha beta. So here what do we have? We have this and that. That's going to be 2 alpha beta. Then this is all going to be minus in brackets alpha squared plus beta squared. So 2 alpha beta minus, what is the expression for alpha squared plus beta squared? We already found that in our previous calculations. Alpha squared plus beta squared is equivalent to alpha plus beta squared minus 2 alpha beta. 2 alpha beta, open bracket, it's going to be minus alpha plus beta squared, this times that is, plus 2 alpha beta. So we shall end up with this plus that is going to give us 4 alpha beta minus this alpha plus beta squared. So our answer here is going to be 4 times, what is in alpha times beta is 3, because according to our the equation given to us in the question, the product of the roots is 3. So it's going to be 4 times 3 minus, according to the equation we've been given in the question, the sum of the roots was 2, so it's going to be 2 squared. So our answer here, we shall end up with 4 times 3. 4 times 3 is simply 12 minus 4, and our answer is 8. So here the product of the roots is going to be 8. So we start formulating our equation by simply saying that It's going to simply be equal to x squared minus sum of the roots is going to be we got the sum of the roots as 0 x plus the product of the roots, which is 8. So of course our quadratic equation will end up being x squared. This term will die, so it's going to be x squared, let's call it minus 0 plus 8. So we shall end up, it's going to become x squared plus 8. We are supposed to find the sum and the product of these two roots. So let's first find the sum of the roots. Finding the sum of those roots is going to be 1 over alpha plus 2 squared plus 1 over beta plus 2 squared. That's going to be equal to alpha plus 2 squared, that's more like now the LCM, beta plus 2 squared. This divided by that, you're going to get this. It's going to be beta plus 2 squared plus this and that. You're going to, this will go, you remain with alpha plus 2 squared. That's going to be beta squared plus 4 beta plus 4. Then we expand this as well. It's going to be plus alpha squared plus 4 alpha plus 4. Divide all that by, now this is the same as saying alpha plus 2 into beta plus 2, all this is squared. So we'll continue with our calculation. This is going to give us so after opening those brackets and ending up with that kind of arrangement, we shall end up with we know the expression for beta squared plus alpha squared from our earlier calculations. It gave us alpha plus beta squared minus 2 alpha beta. This is equivalent to that. We derived it before, we shall not do that again. Plus, so we shall continue with plus 4 into beta plus alpha plus 8. Plus 4 into beta plus alpha plus 8. Divide all that by alpha beta plus 2 into alpha plus beta plus 4, all that is squared. So I think from here we can see that everything has been converted. It is in the form of alpha plus beta and alpha beta. Alpha plus beta, alpha beta. So we shall just substitute. We know that the sum of our roots according to the question is 2. So this is going to be 2 squared minus 2 times 3 plus 4 times 2 plus 8. Divide all that by alpha beta. What is our alpha beta? Alpha beta is going to be 3 plus 2 into alpha plus beta is 2 plus 4. All that is squared. So our answer there is going to become 14 over 121. After finding the sum of the roots, we get the product of the roots. So product, so that is going to give us 1 over this times that. Let's do it down here. That's the product. So it's going to give us this times that is going to give us 1 over alpha plus 2 squared times beta, which is plus 2 squared. 1 over, put all that in brackets, alpha plus 2, that is in one bracket, the other is beta plus 2, all this is squared. So it's going to become 1 over, put that in brackets, the expression is alpha beta, just like we did before, plus 2 into alpha plus beta plus 4. All that is squared. As in alpha beta, we got it from alpha times beta, then plus alpha times 2, which is 2 alpha, plus 2 beta, which is 2 beta, plus 4. 2 times 2, which is 4. So we shall end up here with 1 over, what is alpha beta? Alpha beta is 3 plus 2 into alpha plus beta is 2 plus 4. All this is squared. We end up with 1 over 1 to 1. Like that. 1 over 1 to 1 is the answer we end up with. So meaning here, these are the product of the roots. So the product of our roots is going to be 1 over 1 to 1. So in essence, the final equation is going to simply be x squared minus the sum of the roots. The sum of the roots we got was 14 over 1 to 1, so it's going to be 14 over 1 to 1x plus the product of the roots, which is going to be 1 over 1 to 1. So that's the quadratic equation we get. Equations with common roots are simply equations that share a root. Let's look at this example. Given that the equations x squared minus 2x plus a is equal to 0 and 2x squared minus 5x plus b is equal to 0 have a common root, by eliminating x, show that the root is b minus 2a. So to show that this root is equal to b minus 2a, we simply first write those two equations. And the two equations in this case are x squared minus 2x plus a is equal to 0, and then 2x squared minus 5x plus b is equal to 0. So for us to eliminate x squared, it means that we're supposed to make sure that this value of the coefficient of x squared is the same, so that when we subtract the two, it is 0. So we multiply this coefficient of x here into the whole of the first equation, so that in so doing you make 2x squared also have a coefficient of 2. So here what we shall do, we shall get these 2 and multiply through. 2 times x squared is 2x squared, 2 times negative 2x is negative 4x, then 2 times a is 2a is equal to 0. Then the second equation simply remains the way it is. So we subtract this first equation minus the second one. 2x squared minus 2x gives us 0. Negative 4x minus negative 5x, of course this becomes a plus. Negative 4 plus 5 gives us positive x. Then 2a minus b will simply remain as 2a minus b is equal to 0. So we find our root, which is x, is going to be b over a. And this is the common root. So here we've finished part A, which is telling us to show that this root is b minus 2a. And indeed we have shown that the common root between these two is b minus 2a. So we go on to our next part of the question, that is part B. Part B is telling us to find the expression for the other root of the equation. So in this question we have two equations here. We have the first equation giving us, the first equation according to our question, as you can see, is this. Our second equation is that. And we have known that both these equations share that root, b minus a. So we are supposed to find the expression of the other root. It means that this equation has this root plus another root. This equation here has got this root plus another root. So we are supposed to find the expression of that other root. So we shall begin with our part B of the question. We shall begin with one of the equations, x squared minus 2x plus a. One of the roots of this equation is b minus 2a. So now what is the other root? Let the other root be lambda. So if we say let the other root be lambda, we know that sum of roots, according to from our past videos, we say that sum of roots is going to be equal to negative b over a. And we know that negative b over a is the same as negative into what is b. According to the equation, the value of b is negative 2. So it's going to be negative 2 over a. Our value of a is the coefficient of x squared, which is 1. So negative times negative is positive, and so you'll end up with positive 2. So the sum of the roots is 2. So we simply add the sum of the roots. We know that the lambda, which is the root we are looking for, plus the other common root which we have already proven, which is in essence b minus 2a, not b minus a, but b minus 2a, is going to be equal to 2. So lambda is going to be 2 minus, in brackets, b minus 2a. b minus 2a. So we shall get our answer as 2 minus b. Negative times negative is positive, so it's going to be plus 2a. So this is the expression for the other root for that equation. Then looking at the second equation in our question, the second root for the equation now is 2x squared minus 5x plus b is equal to 0. So let the other root be alpha. We know that the sum of roots is equal to negative b over a. The sum of roots of a quadratic equation are always going to be equal to negative b over a. So in this case, what is negative b? What is b? b is negative 5. So we substitute here, it's going to be negative b, which is negative 5 over a. What is the value of a? The coefficient of x squared, it is 2. So it's negative 5 over 2. Negative times negative will give us positive. So it's going to become 5 over 2. So this is the sum of those two roots for this equation. So we simply go and say, since the sum, we've got the sum of roots as 5 over 2, we go ahead and say that that root b minus 2a, which is the common root that is shared by these two equations, plus alpha, the root we are looking for, is going to be equal to 5 over 2. And alpha is going to be equal to 5 over 2 minus this term. This term of b minus a cancels and comes there. When it crosses the equal sign, it becomes negative this way. So it's 5 over 2 minus b minus 2a. Open brackets here, it is negative 1 times b is negative b. Negative times negative 2a is going to be plus 2a. So its alpha is going to be 5 over 2 minus b plus 2a. And that's going to be the expression for the other root. So let's look at another question here. Given that 2x squared plus 3x plus m is equal to 0 and 3x squared plus x minus 2m is equal to 0 have a common root, find the possible values of m. So these two equations, this equation and that equation, have a common root, and they are asking us to find the possible values of m. If these two equations are having a common root, we shall go ahead and try to find that root. We shall approach this like the way we were doing in our previous calculation. So we shall write down this equation, it is that there, 2x squared plus 3x plus m is equal to 0. Then we have that equation, which is 3x squared plus x minus 2m is equal to 0. Then we eliminate x squared. Eliminating x squared means the coefficients of x squared must be the same. But since in this case they are not the same, we shall get 3, multiply it in the first equation, get these 2, multiply it through in the second equation, so that at the end of the day the coefficients of x are the same, and when we subtract them we are able to get 0. So here 3 times 2 is 6, 3 times 3 is 9, 3 times m is 3m is equal to 3 times 0, which is 0. Then in the second equation it is 3 times 2, which is 6x, 2 times x is 2x, then we have 2 times 2, negative 2 is going to give us negative 4m, giving us 2 times 0, giving us 0. So we have this equation and that equation. So we subtract this equation, this minus that equation. So 6x minus 6x squared will give us 0. 9x minus 2x will give us 7x. 3m minus negative 4m. These two minuses become a positive. So it becomes 3m plus 4m is giving us 7m is equal to 0 minus 0, giving us 0. So this 7m crosses the equal signs to come this way. When this crosses the equal signs, we end up with 7x on this side divided by 7 is equal to negative 7m. Divide that by 7. We cancel out the 7's. You remain with your value of x as negative m. That's our value of x. After finding our value of x as negative m, we are now going to have to substitute this negative m into any of those equations that we've been given in the question, so that we're able to find the range of values for m, the possible values of m. So in this case, it's going to become 3, we get just the second equation, 3x squared plus x minus 2m is equal to 0. So where there is x, we substitute for negative m. And in this case, it is going to be 3 times negative m squared plus x, that is m, minus 2m is equal to 0. So we'll continue with our calculation and say that this is going to become 3. Negative m times negative m is going to be positive m squared plus, this is negative m minus 2m is equal to 0. Of course, this negative and positive will give you a negative value there. So it becomes 3m squared minus m minus 2m is equal to 0. And from there we shall end up with 3m squared, negative m minus 2m is going to be negative 3m is going to be equal to 0. So when we pull out the common factor here, it is 3m into m minus 1 is equal to 0. So here either 3m is equal to 0 or m minus 1 is equal to 0. Therefore, the value of m here will either be 0 or the value of m there is going to be equal to 1. So we've answered the question. The question required us to find the possible values of m, and now we have gotten them. M is either 0 or m is negative 1.